Friends, welcome back. We've come a long way from turning our image into a sequence of patch embeddings. Now, how about we put together all of these sections here into a single cell so we can see it run end to end. So let's start up with section 4.8. Now, you might have already taken on the challenge of doing it, but we're going to do it together anyway because seeing it all in one place is going to help with our understanding. So from image to embedding. So we've written code to turn an image into a flattened sequence of patch embeddings. Now let's see it all in one cell. To start off with, we're going to set the seeds so that we get reproducible results. We don't necessarily need to do this, but I'm just doing it in case. You may have a different image to me, so that's why we may have different results. Just be aware of that. What image do I currently have? I have an image of steak. Now, of course, this is going to change every time you rerun the notebook. So if I run all of these cells, we're going to get a different image here because the training data loader is random. But all of this should run end to end. And so now we want to see it in one cell. So we're going to set the patch size. And we've been working with a patch size of 16. But of course, as you'll find in the VIT paper, there are different values for patch size. Patch size, I believe one of the other patch sizes that they use is 14, the authors. Yeah, VIT huge and a patch size of 14. But just recall, the lower the patch size, the higher number of patches there will be. So let's keep going here. Then we'll go 2. Let's find out the shapes. So print shapes of the original image and get the image dimensions. So this is important to know so that we can calculate n, which is the number of patches. So print image tensor shape, and we'll get image.shape here. And then we'll go height, width. We'll set these equal to our image.shape, and we'll get the first dimension there, image.shape, and we'll get the second dimension there. We'll just see what comes out here. And a little reminder of what our image looks like. It's a big tensor of numbers here. And then if we get the shape of that image, we have color channels, height, width. And I've just rerun all of these cells, so I should have a different image up here. Yeah, another image of steak. And why don't we just rerun all of those just for the hell of it while we're writing some more code down here. So next, what might we need to do? Well, we've got our image height and width. How about we get the image tensor and add a batch dimension? Why do we do this? Well, because our images are going to be in batches when they pass through our network. So we'll create an image called X. X is a generic variable name. Unsqueeze, and we'll unsqueeze it there. And then we can print, let's go input image shape is going to be x.shape. See what comes out there. So we've just added a batch on the 0th dimension. And next, what do we need to do here? Well, we can create the patch embedding layer. And this is where we can use the class that we created before. So we'll instantiate an instance of our patch embedding class, and we'll set in channels equal to 3 because we're dealing with a color image. We don't necessarily need to set these parameters here because by default, we've got in channels equal to 3, patch size equal to 16, embedding dimension equal to 768, in line with table 1. Recall that we're replicating VIT base here, but we've set up our class so far in a way that if we wanted to change the embedding size, we could change it. But let's just stick with a patch size of 16. Well, patch size is going to be patch size above. And then embedding dim is going to be 768. So that's going to be our patch embedding layer. Now we've got an input image and we can pass it through, pass input image through patch embedding layer to create our series of patch embeddings. So patch embedding equals patch embedding layer, and then we'll pass in X which is our batchified image, just up here, X. Now let's find out the shape. So patch embedding shape. Do you see what we're doing here? We're just constantly passing or manipulating data and then finding out how that data is changing. The input and output shapes, oh, I keep writing patching here. Input and output shapes is one of the most important things in all of deep learning and machine learning. So let's now create a class token embedding. So this is the class token of equation 1. If we scroll up here, what we've just done is we've created this. So recall that we're going through equation 1 to begin with. We're putting it all together. We've done each of these parts individually. So now we're going to create the class token and prepend it to the patch embedding. And then we'll create the position embedding. So let's jump back in here. So the class token requires knowing what the batch size is. And we want to do this programmatically. So we'll get the shape. I keep writing patching embedding. So batch size equals patch embedding shape 0. So the 0th dimension there. And then we'll get the embedding dimension. The embedding dimension is the last dimension. So patch embedding dot shape. And we'll get the -1 there. So that's going to be the dimension on the end. I'll just run this so we know what's going on. There we go. So batch size is going to be 1 because we're just using one image. And the embedding shape is going to be 768 because that is the last dimension there. And now we can create the class token. Look at us. So this is where all that work that we've been putting in over the last few videos is all coming together. So torch.ones, I'm only using ones here for demonstration purposes. When we build the actual VIT architecture, we'll use torch.randn to start with a random number instead of a 1. So we'll make sure it's learnable. Now, the class token is learnable because it's in an nn.parameter. If we only used torch.ones, it wouldn't be learnable. So because we've wrapped it in nn.parameter, it is now a learnable parameter. So now let's print out the class token shape. I want to go over here. There we go. So print f class token embedding shape. So we will go class token dot shape. What's next? Well, we said we were going to create. Oh, I'm jumping ahead. We need to prepend the class token to the patch embedding, and then we can create the position embedding and add it to this. So let's go back into here. So we want to prepend the class token embedding to the patch embedding. So patch embedding class token. Variable names are getting a little bit longer here. So torch.cat. We want to concatenate the class token to the front of the patch embedding, which we have above, and across the first dimension. The first dimension being the number of patches here. So then if we check out the shape, so print patch embedding with class token shape. Let's go patch embedding class token dot shape. Let's see what that is. I'll run it again, step by step. There we go. So our class token has a shape of 11768, so our embedding dimension. And then if we prepend it to the front of the patch embedding, we now have an increased shape of, instead of 196, we have 197 because we've prepended this value here. So what are we up to next? Well, we have to create the position embedding. And the position embedding is a series of 1D learnable tokens. So, and we want it in this shape here so that we can just add it onto that. So we'll go create position embedding and we'll set number of patches equal to int. And then we'll go height times width. So we can calculate this. Now this is where we get these values up here, height and width. And technically you could put all of this into a single class, such as patch embedding. And in fact, that might be a little extension that you want to try. See if you can put all of this into the patch embedding class. That'd be a really fun exercise. And then divided by patch size. So that's going to calculate the number of patches. We're doing this programmatically because we never really want to hard code values. Wherever we can calculate things on the fly, that's often a good choice. So position embedding is going to be also an nn.parameter, so it's learnable. That means PyTorch behind the scenes is going to track the gradients and then update them with gradient descent via our optimizer.step. So we'll calculate this as number of patches plus 1, this size, and this is going to be, of course, embedding dimension, which we have already saved. So the embedding dimension stays consistent throughout the entire transformer or the vision transformer layer. Wonderful. And then what do we do now? We can add it. So add the position embedding to patch embedding with class token. So patch and position embedding equals patch embedding class token. So the value that we have above here. So this is what we're replicating right now. This is patch embedding with class token, and we want to add the position embedding. So plus position embedding. Wonderful. And now let's print out. Have we just put everything together? Patch and position embedding shape. So we want patch and position embedding dot shape. Let's see, does it all come to life? No errors? Wonderful, that's exactly what we wanted. Look how far we've come. We started with an image tensor and we slowly broke equation 1 down step by step. We first turned our image into learnable patch embeddings. Then we created a learnable class token and prepended it to those learnable patch embeddings. Then we created a position embedding and added it to that class token and patch embedding. So a fair bit going on there, but we've just broken that down step by step, and now we're doing it in one single cell. So we've got a way to go from an image to, this should be into a flattened sequence of patch embeddings. That is equation 1. We've just replicated equation 1. We've turned it, let's go back to the keynote. We've turned equation 1 into reusable PyTorch code. And now I've said a good extension to this would be we've got a fair bit going on here in terms of creating the class token, prepending the class token, creating the position embedding, and adding that position embedding to the patch embedding. All of this could really be incorporated in the patch embedding class. So my challenge to you is to see if you can incorporate that into this class. And if you do, post it on the course GitHub and show me your code, and I'd love to see it. So just to summarize, then we create the class token, and then finally we create the position embedding and add it to the other embeddings that we have here. So that is equation 1. Now, what have we got to do next? Equation 2. If you want to read ahead, I'd encourage you to do so. See if you can work it out. See if you can map where equation 2 fits into this figure. And otherwise, we'll continue on in the next video.